My name is Juanjo Hierro. I'm the Chief Technology Officer of the FIWARE Foundation, and I will give this presentation. So, when we talk about supporting organizations in their digital transformation, we are thinking on a transformation journey that goes through different steps. In each and every step, and this is what I'm going to explain during this session, FIWARE is bringing standards, is bringing approaches how to do things, and actually, thanks to that, we will be helping organizations to gradually go through this transformation journey. So we will review during this presentation each of these steps, and we will elaborate on the concrete technologies and standards that FIWARE is bringing to organizations. The first step has to do with exploiting data across verticals. And any organization already have a number of systems, each of them solving a particular process, supporting the automation of certain process, smart decisions. But very frequently, all those systems are kind of information silos. So the first step into in this transformation journey we are talking about is precisely about breaking these information silos and enable the whole potential, unleash the whole potential. That means being able to merge data coming from the different verticals. The approach to take is that of building a holistic data representation of context of that organization. That representation will be based on modeling the real physical world by means of a collection of digital twins, each of them with properties who may take values which change over time. And this digital twin representation would be made by means of merging data coming from the different systems you wanna integrate. This might be vertical smart solutions within the organization. It might be different kind of information systems, some of them linked to third parties, and also IoT infrastructures, because you may use to collect that data directly and make it part of this, helping you to build this digital twin representation. Such an approach, where essentially you are building description of context by means of bringing information coming from different sources, allows to create an architecture which some people has described as a systems of systems architecture, where essentially each of the systems are able to publish part of this digital twin representation because they are offering data they hold, they maintain, but also all the systems are capable to consume information that is present in this kind of context management layer that goes across all the verticals. Key properties in a system of systems approach like this is that you can replace any of the systems at any moment. That should not affect the way the whole system is architected, because what would be important is that the system that comes and replaces the existing systems is able to publish the same kind of information, which is what ultimately matters to the rest of systems. It is an extensible architecture because you may add new systems in the architecture. Is a matter of also extending the model of this behind this digital twin representation with perhaps new entities, perhaps new properties coming from that new system you are integrating. And of course, once you integrate a system, rest of systems may benefit of that, may extend their functionality by means of processing the data coming from this system you have incorporated. Loose coupling is another characteristic of a system of systems architecture. The way a given system is implemented should not affect the rest of the systems, and low intrusiveness, since the idea that creating this context management layer should not affect actually the way those systems might be architected. We will go a bit into details on this. What is the technology? What is the standard that FIWARE brings to support this concept of creating a cross-vertical context management layer? This data share space where I hold information about the digital twins that represent the world. Well, FIWARE brings a very concrete standard, which is an API called NGSI that enables the different systems that are part of this system of systems architecture to publish information and consume information. And for publishing information, being able to do it in a push or pull style of communication, so enabling all kind of interaction modes. Also, as consumers, being able to implement either a pull or push style of communication. By pull, when consuming information, we mean applications through this API, systems through this API will be able to perform queries on the digital twin representation that is held and managed through this API. By push kind of style of communication, we mean that a given system may subscribe to given changes in the context. When a given property, like for instance, the speed of a bus, which is an entity in a smart city, goes over certain threshold and get notified whenever this happens. So NGSI is the API that brings access to this information, both for publishing and consuming the information. And that is the essential part of what FIWARE brings to help organizations starting the journey, starting by means of creating a system of systems architecture that allows to break the silos within the organization. I will not go into the details about NGSI. There is a very concrete webinar where the different operations of the API, the characteristics, and so on, were described. I invite you to take a look and check that out, and if you want to learn more details about the API. What is relevant about this API is the fact that it has been endorsed by a number of organizations. First of all, and at certain point, the FIWARE community arrived to ETSI and brought all the developments we have made regarding the API towards standardizing it. Good news is that ETSI produced already a first version of this specification. It already published this in 2019 and keeps evolving the API, among other things, with the very active contribution from the FIWARE community. This standard is called or known as NGSI LD, and and as I said, is now an official standard recommendation coming from ETSI, which is a world-class standard organization, and keeps evolving over time based on the experience we are gaining in designing the different systems and the functions that we have found relevant to incorporate. Another key milestone was the adoption of the context broker technology, which is essentially the component that in any Powered by FIWARE system supports the NGSI API. This was adopted by the European Commission as the basis for creating all kind of smart service infrastructures, particularly smart cities, but also applicable in many other domains, to support the concept of exporting real-time context information, which is essential in any digital transformation. This was adopted under the umbrella of a quite relevant program called Connecting Your Facility, and this, I think, has also helped to bring some warranty to many people. This is something that will remain and actually in Europe will be more and more adopted. This has been very helpful, for instance, when trying to convince globally in other regions that by means of adopting this standard, we are creating opportunities in different parts of the world. We are really creating a global standard. The context broker is therefore the core component we bring implementing the NGSI API. And actually, if we think about what FIWARE brings, it's not just this technology. We bring components that help to capture data coming from the context, from the different sources, not just IoT, but also other kind of information systems, and also components that may help to process that continuous information that the context broker brings access to. Actually, this is a way we typically represent the architecture of the FIWARE platform, how we classify the different components in the FIWARE catalog. We have components that have to do with the interface to IoT, to robotics, to third-party systems. There are components that are helpful for processing, analyzing, visualizing, monitoring information. Of course, there are the core components, which include the context broker, but also a rich family of and suite of connectors to different processing engines and data sinks. And last but not least, components that have to do with identity management, authorization, access control, and components that have to do as well with how to publish information outside the organizations and able to bring support to monetization. Last but not least, a number of deployment tools. Here we are not doing anything else than, surfing the wave of state-of-the-art technologies like Docker technologies or Kubernetes. So this architecture, as it is sketched here, leads to a system of systems architecture like the one we are showing in this slide. This applies, for instance, to smart cities and describes how I can break the silos of information, creating this common horizontal context management layer where we will be keeping information about digital twins, their properties, how those properties change over time, integrating information coming from vertical solutions on one side, also different information sources. For instance, if we are talking about a city, it could be the citizen relationship management portal. It might be social networks. The city might be sniffing to detect relevant information, and also a number of infrastructures, physical infrastructures like IoT, sensor robots, cameras that the city may have deployed. All together is integrated, creating this common space where, for instance, among other things, I will be able to create city-level governance systems, the kind of operation center that many of the cities would love to have. Very important in this figure, and by the way, this is an example of an organization that can build an architecture like this, which is a city, but this same approach applies when we talk about a farm, to give an example. Here, the kind of vertical systems I'm integrating have to do with very concrete processes within the farm, like it could be watering of the fields, like it could be livestock management, the management of the silos, and also information systems, like it could be, for instance, connection to weather forecast services, which in farming is, of course, quite important. It could also apply to the vision of how I can transform a factory into a smart factory. The way we envision manufacturing execution systems, what is typically referred with the acronym MES, can be developed by means of integrating information coming from the different systems and machines in the shop floor on one side, but also different ERPs, information systems like the demand management system, the supply management system, and so on. I would like to elaborate on a couple of details of regarding this system of systems architecture, which represents kind of the first step in the transformation journey, as I explained initially, because I think it's very important when to understand how this system of systems architecture and what is the relevance of this context management layer that is shared across different systems. First of all, is the idea that each of the systems, including the one that plays the role of overall organization governance, is not only about consuming information, it's also about updating that information. And this way, making it available to the rest of systems within the organization. So I may have a system, for instance, at overall city level, and among other things, we might have here algorithms in place to predict, as an example, traffic in a given street. How we model this, how should we design this using Powered by FIWARE approach? Well, such kind of high-level information that is inferred from the more low-level raw data you are capturing from existing systems should also be modeled as properties of existing entities and digital twins in your context information layer. So for instance, if I have an entity called street, what I should do is try to add a property which might be named as time to next traffic jam. This is a property that, of course, you will not be able to obtain the value of by means of reading a sensor, because there is no sensor that is going to give you the information of when the next traffic jam is going to happen. However, the streets may have properties like current traffic, and that might be something you are actually sensing through cameras or through specific sensors you put in the road, whatever means. So what you would have is typically a system. It could be the city level governance systems. It could be the traffic management system, which will be processing the values of the low-level properties of that street, but also information like weather forecast, like the traffic in other streets, like information about events that are happening in the city. And all that together may lead you through a number of algorithms to be able to infer, okay, the time to the next traffic jam is in this particular street is going to be 30 minutes. In 30 minutes, there will be a traffic jam according to my prediction. So that system that made that prediction should write that data into the property you have included precisely to be able to share results of your inference. So therefore, in this digital twin representation of what's going on in this particular example in the city, very important concept is we should not just keep properties that you obtain through sensors, you obtain through systems straight away. You should also use this cross-vertical context information management layer as the mean for sharing results, sharing knowledge. You might be inferring insights, you might be inferring by means of the different algorithms, big data processing, and stuff that different systems connected to that layer are obtaining. So this is a very important concept, is a bidirectional connection of each of the systems that are plugged into this kind of bus or data space that the context broker brings access to. The second important thing is that to a certain extent, all the systems are in the same level. So, and again, this emphasizes this idea of the vertical solutions, for instance, not being only about providing data, but also being able to consume data from these shared context information management layer. Actually, in the previous picture, we were simply giving a tune in the kind of internal architecture of the smart city governance system. But if I take a waste management system, which is one of the verticals in that city, the whole vision looking into the future is that such system may take advantage of this information and exploit this information. And actually, I can have this representation where the application that I have described on top, processing the information and context, and also being able to publish results of algorithms and big data analysis, could be the smart waste management system. in that case consuming concrete, a subset of information. That's true. It's perhaps the difference compared to the smart city governance system is that the smart city governance system will overall take into account all the properties from all the entities, trying to build this support to smart decisions at overall city level. But the waste management system will for sure be processing information not only coming from sensors, but other systems, other vertical systems within the city, and also different information systems that might be relevant. So for instance, the waste management system might be consuming information about public transport, because for instance, you want to avoid that your waste trucks, waste gathering trucks go through streets where you need to really give agile access to public transport. It might be connecting to the traffic management system, because that will be what you will use to plan the routes. And for instance, it might connect to other kind of systems from third parties from the outside, like the weather forecast, because this might be something which might be relevant when planning the gathering of waste. Bottom line, the concept is that through this digital twin representation, by means of relying on this API, what we will offer for a given organization is an approach, a consistent approach for integration of systems and components at multiple levels. So it's something I will rely on when architecting different smart vertical solutions within the organization. I was given an example with smart waste management. It will be the way I will be integrating systems within the organizations to build on top the smart governance systems at overall organization level. And as we will also see later, it could be the basis for exchange of data with other organizations in supporting processes and data value chains that may be quite helpful for development of innovative services. As an example, we might be integrating into the same data space information that the city, the buildings, smart building management systems linked to buildings within the city, smart logistics, even companies, grid companies, energy companies, they could rely on this standard NGSI and this approach to be able to exchange the necessary information to be able to support their process. Coming back to the journey, this was all about the first step in that transformation journey, and how FIWARE technology in the context of broker technology could help and systems be architected. But of course, this is just start of the journey. Second, very important step has to do with collaborating towards creating standard data models that may help to support something that will be essential for building the notion of sustainability in a given a smart domain. Actually, an API per se, we all know, is not enough to ensure interoperability and replicability of solutions. It's the combination of the API and common information models what will allow replicability of solutions, what will allow to take advantage of some of the properties I mentioned before of systems, like the ability to replace a system for a new system, because essentially the interfaces, the kind of information they would publish and consume from this common context information layer would be exactly the same. And this is the kind of right incentives for providers of applications to invest in creating solutions, knowing that they might be plug and play in the architecture of different organizations. What we are doing in that respect is we launch an initiative. We refer to as Smart Data Models Initiative. You can check that out on GitHub. Here you have the link on top of the slide. And there we are defining data models for that can be used in combination with NGSI for a number of domains: smart cities, agri-food, energy, environment, manufacturing, water, smart destinations are the kind of domains we are tackling. And I'm very proud to say that since we launched this initiative, quite a number of organizations and including providers who were developing solutions powered by FIWARE that are contributing models into that space. The combination, and this is something I wanted to insist, the combination of the API for getting access to information describing digital twins, which is the NGSI API, and the smart data models we are bringing here into as part of this initiative is what is helping to materialize in practice the notion of a digital single market of interoperable and replicable solutions. This initiative was an initiative we launched together with TM Forum, quite relevant body, industry body that brings recommendations that are widely adopted in the space of digital service providers, and particularly communication providers. But it's an initiative that is open for other organizations, other industry bodies to join. And actually, we are in conversation with some of them that will join this effort together with TM Forum and us to really come with this population of data models that is actually more and more demanded. The third, these were essentially the two steps in the transformation journey. The third step in that transformation is about exposing data, sharing part of that data outside your organization to foster open innovation. It's the vision that I'm not the one who may have the clarity and all the ideas about what can be done with the data and what kind of services relying on that data can be offered to the customers of my organization, and therefore being able to unleash the potential of real-time data that you may want to share as an organization, enabling third parties, particularly startups, to use that data to create innovative services that your customers will benefit from. What FIWARE has been done here is essentially we have extended the concept of existing open data publication platforms to bring the ability to share data that is not static, that is not historic data, which is what so far open data publication platforms were enabling, but be able to support access to this context information management layer to third parties. Of course, this requires bringing security, access, access control, identity management, and authorization. All these security aspects you need to put in place, because it's only part of the information within your organization what you're gonna share, and also there might be certain restrictions you may want to impose in such access, like for instance the frequency at which potential consumer applications can query for that information, and also ways to avoid service denial attacks and stuff like that. The kind of architecture which, for instance, in the particular case of a smart city, you would be able to build by bringing these additional components that FIWARE offer, extending existing data publication platforms and incorporating a number of plugins to support API management and access control of data exposed through those portals is outlined here. Again, the context broker becomes this common shared data space where different systems are getting access and exploiting the information. Question is that now part of this information will be exposed to third parties export for free, and in this kind of third step in the transformation journey. We are talking about open data, but with certain access controls that will guarantee that there is a proper access to data. That is not the last step in the transformation journey. The last step has to do with enabling the data economy, transforming your organization into a player of the data economy. The fundamental concept here is understanding that a given organization may not have ownership on all the data that could be relevant for the kind of processes it wants to automate, or the kind of smart decisions it wants to support. Therefore, organizations need to get involved in data spaces where other parties, other organizations may be sharing data, and maybe sharing data because they will be able, they will be capable to monetize it. How to bring the incentives for third-party organizations to share data, the ability to monetize and be able to combine and create innovative business models around the support of multi-site markets where players, actors can simply be playing the role of data providers, and organizations are able to consume that data. In this particular step in the journey, we are FIWARE giving response by means of bringing very concrete technology, mature technology that can be used today to build the concept of data marketplace. We are collaborating in this space with organizations like TM Forum, leveraging on the rich set of API recommendations they have created to support concepts linked to service marketplaces. We have actually developed a number of marketplace components based on TM Forum recommendations. And we are also collaborating with IOTA Foundation because in the kind of, if we are talking about monetization, if we are talking about things that will require an accounting, which will be the basis for later on billing or payments, we believe that leveraging on distributed ledger technologies might be quite a relevant aspect as a way to guarantee that there has not been manipulations of, for instance, data usage records and stuff like that. This is what leads to the target and envision architecture at the end of the journey, where again, as a fundamental core vision is this idea of using the digital twin representation of context as the element through which integration is enabled, where not only it's about vertical solutions and information systems providing data and then building organization level management systems on top, is really about enabling each of the systems that are plugged in this cross system context information management layer and allow them to both publish and consume context information model as properties of digital twins, making part of that information visible through a data marketplace, and part of this information being able to be priced data, and of course enabling right-time data sets that other parties may consume. Integrating not only access control, usage control, identity management elements, but also complete set of business operations support components that will take care of whenever you are exchanging data and exchanging data for or consuming data, and this may have maybe data with a price, be able to do a proper accounting, rating, billing, and settlement for the payment later on. That is very important, a vision that does not only apply to cities, also applies in other domains like agri-food. And we really envision that, for instance, farms of the future will not be only about integrating systems in farm management systems using this digital twin approach. It's also about farmers being able to exploit their data and being able to offer that to parties and be able to monetize that. Same happens in energy because the pattern ends being the same, and this is also the beauty of the kind of the standards that FIWARE are bringing, helping any kind of organization to become a smart organization. The kind of pattern, architectural pattern, will be the same, could be extrapolated. As a summary of what we have touched today, the 4 steps in the transformation journey. First, focus on exploiting data across verticals, breaking information silos as a second step, helping to achieve true interoperability and replicability of solutions, to the extent later on to evolve to support open innovation, and last but not least, bringing organizations as protagonists of the new data economy. Bringing at each of these steps the necessary standards, the necessary technology that will give response to how to materialize that step, and how the architecture of the organization, the systems architecture of the organization could be designed, avoiding vendor locking and this way protecting the investment. That was all I wanted to explain today.